Good morning, everyone. First and foremost, I would like to thank you on behalf of Synergix International for coming to our seminar today, which is for Versiv as well as Fiber Excellence. I see quite a few familiar faces here. For those of you who do not know me, my name is Mike Kazemian. I'm the managing partner for Synergix International. By education, I'm a mechanical engineer, but by trade, I've been in this field for over 18 years, and I've been in Dubai for an extent of like 14 years. Today I'm going to talk a little bit about fiber optics with you. I want to have a better understanding of what you know, so we will be starting by asking some questions. It's going to be interactive, and then we will move over to what you need to do in order to basically do testing for various things on the fiber optics. We're going to go through the practices that we need to do. So those are very critical for us, so you need to understand that. We're going to talk about standards a little bit. So I'm not going to talk about the product that much. I'm going to talk about the technology. This is the agenda that I'm going to cover for the latter half of the day until lunch break. Before we start, I would like to ask some questions from you to get a better understanding of where we are standing. How many of you have used fiber optic certification tools? Raise your hand. 2, 3, 4, 5, 6, 7, 8, 10. Good. About 30% of you have used the fiber optic certification tools. How many of you have used DTX 1800? Good. All right, more than 30%. How many of you have used the single mode multi-mode fiber modules from Fluke Networks? Good. We have some fiber people here. Excellent. How many of you know what is TRC? Ever heard of TRCs? Okay. Good. We're going to talk about that today. How many of you use regular patch cord to do a set reference on fiber optic? We have 1. Okay. 2. We have a person from Thales. Okay. How many of you use TRC for set references? Okay. So I want to make a separation here. Who's using a regular patch cord and who's using the TRC for set reference? First of all, the regular patch cords. I have a Thales person there. No? Okay. Who is using TRCs for set reference? Okay, good. How many of you know what is encircled flux? We'll be talking about that as well. How many of you have heard of DTX EFM2? Okay, done. How many of you know about the standard 14763-3? This is a very critical standard for fiber optics. We will be discussing in the latter half of my presentation. Sorry? No, it's a standard. It's a standard from ISO 14763-3, also Synergix. How many of you know what is graded fiber index? Graded fiber index. Ever heard of fiber called OM3, OM4? They use this technology. We need to discuss what they do and why you use this, which is a lot more expensive than regular fiber. Okay? And how it works, which is quite critical. Okay? How many of you have installed MPO and MTP? Multi-port push-on. All right, very good. How many of you have used or tested MPO-MTP? Data center people, come on. This is the future. We are going from 2014 to 2020, 90% of the links will be 40 gig. And it has to be used, you have to use MPO-MTP. No other option. And you have to know how to do the testing for MPO-MTP. It's quite complicated. All right, so we're going to start from the basics today and see what we have. Fiber optics. Usually a fiber optic link is, the component itself is composed of several areas. Most of you know about it. We have a core, we have a cladding. The core determines whether we have a multi-mode or a single mode. 9 micron usually is the multi-mode, 62.5 and 50 micron is the multi-mode. And then the cladding is always 125 microns. So we have the core, we have the cladding, and then we have the yarn or we have the buffer on top of that, depending on the type of the fiber optic cable that you have. Okay, now, can anybody tell me okay, you can see the center of the ferrule, that is the core?
Yes.
Yes? No? Yes or no? How many S's? That's, so you're saying this is the core? What is it? Core is not visible. What you see here is what we call cladding. Okay? That's 125 micron cladding that you see. Core is not visible by the naked eye. You need to have a scope. Alright? Now, the light, of course, will go through the core, and there's two technologies behind the light that goes through the core. One is the single mode, one is the multi-mode. By single mode, what we're talking about is only there's a single mode of light that goes through the center of the core, and the core diameter, as I said, is 9 micron, and it has a different kind of transmitter at the top that we will be discussing, and then the other portion is the multi-mode, which the fiber will go in the multi-modes. So there's multiple modes of light that goes through the fiber. Okay? And there's some complications in there. I'm not going to discuss about various things here because it's complicated. On the connector side, we have various types of connectors. The ones that you see here are for a single core. So that means we have a square connector, we have the ST, FC, MIC. They carry only one core. However, for fiber optic, most of the time, especially in the LANs and multi-mode, you will need two cores, one to send, one to receive. In the single modes, with the new technology, especially fiber to the home, you can send and receive on the same core. They call it single core dual channel. And that is what Etisalat is delivering. You have a single core that will transmit two wavelengths. One has a filter one way, the other one has a filter from the other way. So you can easily reduce your cost by half on the cabling, and you can transmit and send on the same core. And by the way, our Versive can test FTTH cable. So it's a single core dual channel. Okay? And the other type of connectors that they carry two fibers, send and receive on the same bulkhead, that's what we call small form factors, and there's various ones. The first one was MTRJ, and then we have the LC, which is quite now common. We have the BF45FJ. There is quite a few form factors that are available in the market. MTP, MPO is what you see over there. You can run up to 12 fibers on the same link. I have a piece of fiber here that does that. That makes the life of the installer quite easy. You order these pre-terminated, and you can send up to 12 fiber links into this little cable that you can see. The next version will be 24 on this. So you can see we are going in a different direction now, especially with the data centers where we have high density considerations and we want to have immediate installations and availability and so forth. So that is the direction that for the data centers most people are migrating to at this moment as we speak. And then we have the cassettes that we have to worry about, which will convert the 12 from one core into individual cores that you can connect to your active devices and passive devices. By the way, nowadays you can even have the technology that on your active devices you will have MPO ready ports. So you can get, like if you are into Cisco Nexus 7, They have port, they have modules that you can install. They can run an MPO, and you can have up to 100 gig transmission on a single port. That little module will cost you $26,000. That's besides the point, but eventually these prices will come down. So you can directly connect MPO into your active devices as we speak. There's multiple vendors that they do that. Okay. One of the biggest problems with the fiber optic that you have to worry about when it comes into test and measurement is attenuation. And attenuation, they have multiple reasons for it. One of them is the macro bending, or micro bending, which will cause the fiber to misbehave. The light will escape through. We'll discuss that later, what will happen. So the other thing is the impurities that you have in the fiber. It is less common nowadays. Usually the quality of fibers are quite good, but usually these are the sources of attenuation. So you have to be very careful on how to treat fiber when it comes into bending. Other sources of attenuation, intrinsic ones, are two that what we call Rayleigh scattering. That's when it happens when your light is basically stronger than the absorption capabilities of the glass molecules, so the light will scatter everywhere. And that's the technology that OTDR uses to find out where the breakage point or coupling points are. So that's the technology that we use. The other one is what we call absorption, and that's when your lights are at the same wavelength as the basically energy level of the glass molecules, so they get absorbed. So these are the intrinsic reasons for the attenuation. And then you have, of course, splice losses, fusion core alignment, especially in data centers, is quite critical. We're going to spend some time on that. And then we have on the multi-mode, especially we have mechanical core alignment, dust, which is number one enemy, on the end faces, which will make the link misbehave or lower its performance. Sources of attenuation, as I said, coupling mismatches are quite common. In this first one, area mismatches is when you have, for example, 62.5 micron connected to 50 micron, or you have single mode connected to a multi-mode. This is what we call area mismatch. Spacing losses, which has to do with the quality of your structured cabling connectivity, especially the couplers. Then we have access misalignments, which happens also with the ferrule. Ferrule is quite fragile, and it has to be very precise. So this happens especially in data centers with very high, very low loss budgets, and very tight headrooms. You need to be very careful about access misalignment. We're going to discuss this, why and what will happen. And then angular misalignment. Angular misalignment usually happens when you have, let's say, angle polish connectors for the single core dual channel connected to a regular ferrule, what we call PC or UPC. The tip of the ferrule itself is divided into three areas. One is what we call PC, which is a regular one, polish connector. The other one is UPC, which is ultra polish connector, and the other one is angle polish connector. These performances are variable, so if you have an APC, you have to use also APC connect ferrule type. You cannot go straight one and angle one, of course the light will escape through. And also on the APC, be very careful. There is two types of APC. Anybody knows what are the two types of APCs? Angle polish. How many have you done fiber to the home for Etisalat? 1, 2, 3, 4, 5. Okay. Anybody knows what are the two types of APCs? Be very careful. That causes a lot of confusion. There's an 8-degree and there's a 9-degree. You have to choose the right one. You have to be unified. If you go with the 8-degree APC, always stay with the 8-degree. If you go with the 9-degree, go with the 9-degree. If the vendor doesn't specify, ask them. Good vendors usually have both of them and they specify. Okay? Or you can ask also from Etisalat, and you will confuse them. I've seen a lot of confusion there. Okay? So, now, one of the things that happens in the fiber is what we call dispersion. When the signal goes across into the fiber link itself, basically due to different things, the signal, because you transmit, you encode the signal into the fiber, it goes to the other side, the receiver receives it and is supposed to decode it. Now, if the quality of the signal is not the same from the transmission to the reception side, also the receiver cannot decode, so it will request another request for retransmission of the same signal. So that will cause overutilization in your network. Okay, and there's different reasons for it. And what they have done is, one of the things to overcome that issue, especially in longer distances, this will happen. In shorter distances, it will not happen. But in longer distances, it will happen. What they have created is what they call graded index fiber. And I will explain to you later on what it is. And also single mode fiber will also reduce the amount of dispersion that you have. As you can see here, it's a neck-driven parameter. Okay, now the chromatic dispersion is basically the transmitter itself, the light source that will transmit the signal. They have different wavelengths, and it, depending on the situation that you have, that can have effects on your fiber, so you have to somehow compensate it. So sometimes use LED, sometimes use laser, VCSEL, there's different kind of light sources that we use that we'll get into later on. However, the factors between these is the costing. Laser is most expensive, but VCSEL is a little bit cheaper, and then LED is the cheapest one, and each of them have their own pros and cons, which we'll discuss. The laser source, the most well-known laser source is called the FP or ferry port, and that one has a 1 nanometer width, and the amplitude is the standard amplitude as with any other devices. It will transmit at the window of 1310 nanometers and 1550 nanometers, and usually this is a narrow beam. Usually is used for single mode applications. VCSEL, however, is a vertical cavity surface emitting laser, and that one is used when you want to have high-speed transmissions into the multi-mode area. It transmits at the wavelength of 850 nanometer and 1300 nanometer in these two windows, energy windows, and it is quite narrow. It's not as narrow as FP or distributed feedback. That's the other type of laser, DFP, which is not mentioned here, just to tell you what it is, called distributed feedback. So these are the two types that we have available for the laser on the VCSEL side, which is for the multimode. That is available. The other third light source, which is the cheapest one, is called the LED or light emitting diode. It runs at 850 and 1300 nanometers, and usually the width of the transmitted signal is usually 15 nanometers instead of 1 nanometer here. Okay. Now let's see what will happen inside the laser, inside the fiber itself. If you have a laser, it's very intensified, single transmission in a single mode, long distances that you can transmit, and of course you get higher bandwidth. When you go into VCSEL, as I mentioned before, it's not as wide. However, you can see the optical output of a laser, which is runs into the between 30 to 40 micrometers or 50 micron range. You will see later on that this guy will cause a lot of problems if you have this on a tester. Okay, so that means the light we are talking about. Anyhow, if you have a switch or a router that has a fiber port, they will be using one of these three, which is okay. But when we come to the testing side, when you have something like this, the light source becomes quite critical in proper test and measurement results. Okay? So if you have a VCSEL, as you will see later on, you see the light has a whole bunch of speckles. And so that means the transmitted light is not unified. From one VCSEL to VCSEL, it varies. So that means if our tester had a VCSEL port, what would happen is from one, you would have, let's say this gentleman will have one tester, and he will test and he will get a pass. The next gentleman, he will take the same from the same manufacturer, he will take a tester, and it will be a fail. So the question is whether you have a fail or a pass. So VCSEL, usually due to the variability in the light that it transmits, is not a proper light source for test and measurement. Please make sure whenever you purchase a certification tool, especially on fiber, ensure that it is not Excel. You will not be getting repeatable results. The third type is what we call LED, light emitting diode, and that one you can see it's overfilling the basically fiber core, but it is uniform. So that means from one tester to the other tester, the light that is transmitted is uniform, which is quite important. Ooh. Okay, so now in the theory, they say this is the best to use for gigabit Ethernet, and because you're not overfilling the lighting to the fiber itself. You don't need a mandrella and a lot of other things, but in the real world, it will not work. You will see why. You see the light speckle change? It changed from one to the other, so it's just variable, and you will not get repeatable test results. Now, from the operational side and from the costing of the bill of quantity as well, you have to realize the pros and cons of each of these two different technologies. The single mode, the cable itself is cheaper. However, splicing is a nightmare and it's very expensive. You have to have a fusion splice machine in order to be able to splice a single mode fiber optic cable. Transmission distances are longer, of course, with the single mode, as well as you have a higher bandwidth and capacity. So you can run 100 gig, or right now they're talking even 140 gig on single mode. On the multi-mode, the cable is more expensive. Splicing, you can do a mechanical splice and you can get away with it. So the costing of the splice machine is not there. You run shorter distances, and of course, you have lower capacity. So the bandwidth is not as much as the single mode. Okay? One of the most important topics that everybody oversees regarding fiber optic is your cleaning regime. It is very, very important to constantly, as a preventive maintenance for those of you who are doing installations for customers, you have to tell them that you need to do preventive maintenance. That means that once you do the installation, you go home, that's not the end of the day. You have to constantly come, inspect, clean, and then reconnect. This is a regular thing that you have to do. So we are going to talk about that portion a little bit. Dirty faces are number one cause of fiber failure. It composes of 85% of all the failures. This is a realistic number, which not many people realize. Okay? Dirt is everywhere, it floats, transmits on the skin, or skin is oily, and then inside the dust caps, everybody thinks that if you can put the cap inside, this will protect. It will protect, but itself, if it is dirty, and if it is negatively charged, and then your port is positively charged, you will get cross-contamination. It will just jump from inside the cap to on the fiber port itself. So it's quite critical to be aware of these issues as well. Okay? And now, as our data rates are becoming more and more on the higher side, and they're getting increased, and they're talking 40 gig and 100 gig and 140 gig, at the same time, your budgets become smaller and smaller, so it is more imperative and important that you need to clean and inspect to improve your headroom. If you don't do that, you will fail. It's guaranteed, especially in data centers. Okay? Alright, now this is what we call contaminants family tree. We have two types of groups. One we have ionic and the other one is non-ionic. The ionics are salts and body oil. Like here we are humid, so we have a lot of ionic contaminants. Then we have on the non-ionic one, we have the polar, and we have non-polar. Polar, the airborne dusts and dirty dirt particles, and then the non-polar ones are the things that are inside the fiber, like the gel and things like that. Okay, now some misconceptions about fiber cleaning practices which we want to enforce here and inform you about is number one, things that come from the factory and they have caps on them, don't trust it. Always clean. If they come in a bag and everything, make sure before installation you inspect, you clean, and then you install. Do not take anything out of the bag and install. They will not work. Even the switches that you buy, your patch panels that you buy, brand new, inspect. Please inspect. The other thing is a lot of people use air spray cans to clean the ports. You make things worse. It is not the proper way to do things. You will even impose some bigger particles on the end faces of the fiber itself, and it will cause more harm than good. The other thing that we have seen quite common, as I said, in this business for 15, 16 years, and I've seen it since day one, is a lot of people are using alcohol. How many of you are using alcohol to clean? 1, 2, 3, 4. How many of you even clean fiber? Some people even don't clean it. So 4 or 5 people are using alcohol. Is alcohol the proper solvent to clean fiber? If yes, why? If no, why?
If it's pure water, it's okay. If it's 99%, some water is mixed with water.
Okay, and what will happen if it is mixed with water? 2 things are in the alcohol. One is water, you're right. The other portion is the isopropyl, which is the alcohol portion of it, okay? Now, what is the, it's very logical deduction. What is the boiling temperature of alcohol? Room temperature, right? What is the boiling temperature of water? 100 degrees. So when you attempt to clean, the alcohol portion evaporates, the water will remain there, and the dust will sit on top of it. You'd make things worse. Do not use the IPA or alcohol when you do cleaning. You have to use the proper solvent. The other thing that you have to remember, nowadays there's 2 types of fiber optic available. What are the 2 types of core? Nobody knows? One is the glass core, the other one is the plastic core. And some plastic cores are very, very sensitive to alcohol. And you will even make the whole face, go, just rub some alcohol on plexiglass, you will see it will just go mate. So you cannot even transmit lightly. So you have to use the right cleaning solution for doing fiber optic cleaning and maintenance. There's different vendors that they have it, we have it as well. Okay, we have a specific solvent for cleaning fiber. It's not alcohol based. Okay, now, when you want to do cleaning, a lot of people do this portion, but they forget about this portion. You have to clean both sides. In order to clean, you need to basically inspect the end face, apply solvent, okay, and then dry it out, and then inspect again, and if it is dirty, then clean again, inspect again, clean again, and so forth. So you always have to go through this cycle and ensure the fiber is clean. Alright? On the ports also you have to do the same thing, but the difference between here and here is that this one is easier, whereas this one you have to use a specific or special cotton swab that can go inside the port. So what you do basically, you just put a dab of solvent on it, which is proper for this. You rotate it 3 times. You will take it out. From the other side of the swab, which is the dry side, you rotate it three times on the same side, and you will clean. And I'm sure that once you do the inspection, you will see it's clean. But again, you can re-inspect and clean. What are the proper tools? How many of you are using these microscopes for cleaning? 1, 2, 3, 4, 5. Good. Okay. Well, that will take care of the main portion. What will you do with the female part? That scope cannot be used for the female part.
Yes, you can use it if you have connectors.
Yeah, but you will not get, there is a better way to do it. We have also that as well. However, this type of scope is a lot easier to use. It can check for both male and female. And our Versive, it can also certify the end face, and it can document it for you when you do the fiber testing. So you just connect this guy here, and then you can do male and female both, because it has different end faces.
What does it document? It documents the image of the...
Yes, it documents and it certifies the end face, whether it's a pass on the end face or fail on the end face. Correct.
The image itself.
The image itself, yes. The other thing that I do not recommend use this one, not only from Fluke, but from anybody. Can anybody guess why? Yes, you will magnify and you will go blind. Exactly. Unless it has a filter. And if you don't know whether the data is on there or not, and you don't know whether the filter is there or not, then it's not a good situation for you. So the best way to do it is this way, or this way. This one will document. This one has 2 levels of magnification. This one is single magnification. This is a little bit more, you can put it on your belt or something like that. So it's this one is the one that is quite common that we use. Yes. It comes on the Optifiber Pro. You can get with the inspector. Yeah. Also on the optical loss test sets, this one as well, which is the optical loss test set. This one, you can also get that as well with the inspector. So it can be obtained. All right. Now the way we clean is you need to have a lint-free, first of all, cleaning material, which again we supply. You put it down.